So you have to know first basic concept in gradient based learning. So we have two terminologies here, linearity and non-linearity. We have discussed this in the previous classes itself. Linearity and non-linearity. What is meant by linearity and what is meant by non-linearity? What is linearly separable and what is not linearly separable? I mean, not linearly separable means in a with the be louder. What is linearly separable?
Single function.
A single function classifies two different classes are right. So here, for example, you have class and here another class. Okay. So this line separates two different classes, which means that this is linearly separable. Right. So there are some cases like cluster, which includes two different shapes. I already told you guys, these are circles. These are triangles. Okay. So in this case, we can able to separate this using this line easily, linearly separable. For example, if you are having as a cluster, this would not be possible by using linear line. We cannot separate this, right? So these are non-linearly separable, not linearly separable. So there are two concepts, linearity and non-linearity. So we can able to solve the linear problems easily using linear regression and some other algorithms. But non-linearity problem is very difficult to solve. Using the neural networks, we can able to solve the non-linear problems. That is the main advantage of neural network. So in order to solve the non-linear problems, we are going for neural networks, right? So before that, you have to know how we are solving linear problems, right? Either it can be a straight line which classifies two different classes, or it can be a squiggle we can have in the graph, and likewise, or it can be clusters, whatever it is. Non-linear things can be easily solved using the neural networks. Okay, consider the first one, which is a linear one, right? We can able to classify two different classes, right? So the linear equation for this is, for example, y is equal to, what is the linear equation? Y is equal to a x plus b. Do you remember? This is a normal equation, right? We are representing this as h. For example, we are taking y-axis as height and x-axis as weight. Okay. So y is equal to ax plus b is the linear equation, right? So in our terminology, here we are taking intercept. So we are this as intercept and slope as a, and height and weight are the variables here. We are taking y variable as height and x variable as weight. So we are redefining this linear equation as height is equal to for predicting height is equal to intercept plus slope into weight. That is a into x, weight plus b is the intercept, right? So in any kind of things, whether it can be a line or squiggle or it can be clusters, non-linear things can be solved easily using the neural networks, right? So first you have to know the basics of gradient descent. This gradient descent algorithm in linearity will be used for solving, used for optimization. It is a kind of optimization algorithm, right? So for example, assume in this equation, take this as our problem, right? So in this equation, assume first the intercept is equal to 0 and slope is equal to the value of 0.64, okay? Intercept is equal to, assume intercept is equal to 0 and slope is equal to the value of 0.64. Slope into weight.